Hello, and welcome to the pre-class video for the effects of exercise on short-term memory. In this video, I'll briefly be introducing three major points, which we'll discuss further tomorrow. The first point we're going to discuss would be graphing and finding relationships. The second point, we're briefly going to introduce the circulatory system, which then brings us to our third point, oxygen flow to the brain. Let's go on. Graphing. Graphing is used to find a relationship between two variables. I took the liberty of pre-making an example for you guys and writing it down on the board. So a group of scientists at a prestigious university want to find how much CO2, carbon dioxide, a culture sample of yeast, a fungi, produces when given a certain amount of sugar. To do this, they set up an experiment where they would place a culture sample in at least 3 different containers, and they would put the same amount of yeast and warm water in each container. They would vary then the amount of sugar they would place in each container, starting with 1 tablespoon, as seen here, and then they would go up by increments of 1, so 2, then 3. From this, they would collect how much CO2 was produced by placing a balloon on top of the bottle, so it completely encapsulates it, and the CO2 would then rise up to the balloon, causing it to expand. This expansion of the balloon would increase the diameter of the balloon by a certain amount, which we'll be measuring here in centimeters cubed. So identifying variables. We have this given experiment. So what do we know? We know that scientists have a culture sample of yeast, and they want to find out how much CO2 is produced when sugar is added. So as we look in the definition of independent dependent variable, an independent variable is a variable that's being tested and changed in an experiment. So we have the yeast. We start off with the yeast. We would call the yeast our control variable because the yeast is the baseline for what we're starting an experiment with. So the yeast in the containers with the water is uniform throughout until something's done to it. So that would be our control. What we change to the experiment is then we add the sugar in tablespoons, which is our set quantity to measure. Because the sugar is being added and is causing an effect on the yeast to produce a certain amount of CO2, we would call this the independent variable, which we represent in our x-axis here. And the reason so is because the sugar is what's being tested. Different amounts of sugar produce different results. For our dependent variable, we're looking into how much CO2 is produced for every time we add a different amount of sugar. So if we add 1 tablespoon of sugar here, we saw that the volume of the balloon would go up to 10 centimeters cubed. If we add 2 tablespoons of sugar here, we saw that the volume of the balloon would go up to 20 centimeters cubed, and 30 centimeters cubed. So because the volume of the balloon is changing and different amounts of CO2 are being produced, we can assume that the volume is a dependent variable to this experiment, which we represent in the y-axis right here. So we have our x-axis for independent and our y-axis for dependent. So independent is what's being tested, dependent is what's being measured. So let's write out this experiment here. We have the data table with our x-axis and our y-axis, our independent, dependent. And if we were to graph this, for 1 tablespoon of sugar, we produced 10 centimeters cubed volume of the balloon. So 1 right here for the tablespoon and 10 right here. So we match it up in the middle and get our first point. For our second point, it will be 2 tablespoons of sugar for 20 centimeters cubed in the diameter balloon, volume of the balloon. So we would match it up in the middle right here. And for our third data point, it would be 3 tablespoons of sugar, which would match up with 30 centimeters cubed of the volume of the balloon. So we would match it up here. So those would be our 3 data points. Now what can we do with this, just looking at the that? So as we see in the data table, we have the order of how the experiment was conducted. So we went up by 1, 2, 3. So for each of these trials, when we plot it out, we get a set of data points here. And to find a relationship with this, we would have to find, so we have the 3 data points here. From this, we can connect them. We can clearly see from this connection here that there is an upwards increase at a certain rate for the amount of tablespoons of sugar added in the volume of the balloon. So we have a line here, and you can clearly see, seems like there's some form of correlation on it, but what if we want to find out exactly how much it was? Well, to do that, we would find what is called the change or the slope of it. And the way we do that is we take 2 points and we find out how much change between each point, your higher y, and then you subtract it to your first point, your lower y. And then you would divide the whole thing by your second x, and then subtract that second x from the first x. So here you have it, y2 minus y1 over x2 minus x1. So if we were to apply that in our table here, I chose 0.3 and 0.1. So 3 tablespoons of sugar and 1 tablespoon of sugar. And as we can see here, for 3 tablespoons of sugar, our volume was 30 in centimeters cubed. And for 1, it was 10 centimeters cubed. So 30 minus 10 tablespoons, or x, it was 3 tablespoons of sugar for the second point, and 1 tablespoon of sugar for the first point, and 30 minus 10 equals 20, and then 3 minus 1 equals 2. So we have 20 over 2. Now, to find the slope form and the basis form, we have to simplify that. And as we know, 20 minus 2 is equal to 10. So our slope is 10 centimeters cubed for every tablespoon of sugar. So we have the slope. So we know for each tablespoon of sugar, we get an increase of 10 centimeters cubed in the diameter of the balloon. So the reason this slope is important is because using this slope, scientists can find out exactly how much CO2 the yeast can produce. So for each tablespoon of sugar, we get an increase of 10 centimeters cubed in the diameter of the balloon. But another interesting point I want you guys to keep in mind is, from this, we were able to find a direct relationship with this. And why do I say direct? Well, it's because we have a positive correlation. So a direct correlation is a positive correlation. As we saw, for each tablespoon was added, the volume of the balloon, or the amount of CO2, went up directly positively. So the more tablespoons of sugar, the more volume is positive. Now what will happen if we have some anomaly, and let's say on our third point, when we added 3 tablespoons of sugar, by some defined law of chemistry and physics, we would have a negative point, and the volume of the balloon would be negative 10. Well, when we factor that into the slope, we would now have the y2 be negative 30. So if we were to calculate that and put it here, it would be negative 30 minus 10, which would come out to negative 40 over 2. And if you calculate that, you'd get a slope of negative 20 per each tablespoon. Well, if that were the case, then that relationship would be considered indirect. And an indirect relationship is, for an increase of x, you have a negative y. So that was graphing. We reviewed how to find an independent dependent variable. We also reviewed how to find a slope based on 2 points, which is our change. And from that slope, scientists can now accurately identify what would happen if they added a 4th tablespoon or a 5th tablespoon. And finally, we discussed direct and indirect relationships, where a direct relationship, or positive correlation, versus inverse correlation, where in this case we had a direct positive correlation, where for each x we had an increase in y, and for an inverse correlation, where for each x we had a decrease in y. And that is graphing. We'll then be discussing now the circulatory system, and for that I'll be moving over to my colleague. Thank you for your time.
Our breathing pattern has profound effects on the brain. Your brain requires oxygen to function, and oxygen reaches your brain through the blood. Changes in breathing can lead to less oxygen in your brain and reduce brain blood supply by 20 to 30%. How should we breathe to ensure maximum oxygenation and cerebral blood flow of the brain? How should we get more oxygen to the brain? A way to increase blood flow to the brain is by exercising regularly. There's even research that concluded moderate exercise improves blood circulation to the brain. Research shows that when we exercise, blood pressure and blood flow increases everywhere in the body, including the brain. More blood means more energy and oxygen, which makes our brain perform better. Working up a sweat enhances our mental capacity, specifically in the hippocampus, a part of the brain critical for learning and memory. When the neurons in this structure speed up, our cognitive function improves.